No, I was just going to say, you're talking about culture being the biggest impediment to integrating new ideas and new approaches into the workforce. But so how do you establish then, and you talked some about this with the generalist piece, but how do you establish a culture of data-driven decision making?
The way we did it was through action, showing what we're able to do to engineers and operators when we did it. We never walked in, solved a problem for them, and left. And typically we would find somebody or more than one somebody in the plant that says, oh, that's really interesting. How did you do that? And we take the time to show them. We developed training programs globally across the company that people in my organization would take a week out of their time to go do and get large groups in. None of our highest order data computational experts would ever walk away from the opportunity to buy a license for an engineer and show that engineer how they did what they did. Because the people that reported to me knew that the only reason they were working for me was I wanted to propagate them as much as possible. And the only way to propagate was to hand knowledge off to other people. Fortunately, I worked for a company that was very open to sharing knowledge and not trying to keep it in little groups so that people down the way wouldn't look better than you. All right. So there's training, there was walking the line, and then there's a book entitled Analytics at Work by Davenport and Harris. And there's a precursor to that, Analytics in the Workplace, or let's see. Oh, Competing on Analytics. Competing on Analytics was the first book, and Analytics in the Workplace, the second book. The very first thing they say in the first book, if I had read that before I got started in my trek through Dow into all these things I did, if I'd read that book when it was published, I probably would have turned around and not done what I did. Because they said that in order to achieve true analytic data science revolution in a company, the CEO and the board of directors needs to understand its value and lead the charge. Otherwise, you'll fail. And they said that's true for maybe 1% or 1/10 of 1% of all companies. The rest of the companies has to have a champion at some level, and I was at the right level at the time when I started to be there, champion to bring that change and bring the new opportunities to the company. I had to set aside discretionary time to spend a lot of time talking to executives, bringing examples, creating stories around the data analytics we did, bringing these stories forward and talking to people. And I had good friends of mine, brilliant scientists, brilliant engineers tell me, Lloyd, why are you wasting your time? You're never going to change minds. You're never going to change hearts. Well, I did. But I'll tell you, if I hadn't tried that, I would never have been successful. We would have never accomplished what we did. You have to spend time managing up while you're managing down, getting your people the resources they need to do the job that they want to do, not asking too many questions, but then going up and saying, this is what they've done. Remember, remember, remember. It was a quarterly pilgrimage to my corporate headquarters to remind people what we were doing for them. And the most gratifying thing I had from a vice president was when there was an argument about where they needed to be cutting in the company. And he said, well, if you cut the analytics group, I'll take them all into my business. We'll employ the entire organization in this one business. Well, you can't do that because then they'll stop doing stuff in our business. That was when I knew we were going to be successful, when we have the executives arguing over who gets our time. And you wonder, well, why don't we go out and buy all the software or hire more people? Well, nobody runs a business that way. Soothsayer doesn't run a business that way. It's an interesting paradigm that people seem to forget, but you've got to make money in doing anything you're doing, and then you've got to tell your executives how much money you're making for them. And oh, by the way, during these conversations, I would also tell them where I wanted to go. I would pitch a vision for the analytics in my company that was so far out there, there was no way I was ever going to see us get there. Because if I was able to give these incremental improvements now. That dream didn't seem so ridiculous. You know, and some of them were pretty far out, okay. But we see people in industry today, especially in the IT industry, Chris, and you know who I'm talking about, promising things that they cannot deliver. And part of that, though, does have a position to inspire people to at least think about that. I got a lot of you're not going to be successful. I've tried that before. It's not going to work. But you've got to manage all the different aspects of the human enterprise in your company to be successful at this. Support your people, get the right resources in, maybe break a few of the soft rules in the corporation to get things done, and talk to the senior management to tell them what you're producing today. And oh, by the way, in terms they can relate to: return on investment, hard dollar savings, soft dollar savings, increase in capacity in MAC, the ability of a plant to make something. Whatever the individual I was talking to, I already knew what they wanted. I already talked to enough people to know what I needed to say to give them the right information at the right time, and to never argue with them if they didn't like what I had to say. I would just redouble my efforts.
So let's take it there then. With regard to the hard dollars versus soft dollar issue, you talked about most data projects in chemical manufacturing being more on the soft dollar side. So how does one make the case for a project when it may not directly result in dividends back to investors? And more broadly, how do you measure the success of these analytics initiatives and communicate those results to management and to senior management? And so let me make it shorter. Can you talk about the economics of data science in the world of chemical manufacturing?
So let me explain hard dollar and soft dollar, because I explained that in an article I gave you, but I haven't done it here. Hard dollar savings is if I spend money on something and I improve a plant. For example, I bought AI and installed it in a plant to help me improve the pounds out the door of that plant. And that plant is sold out. So every additional pound I make is hard dollar savings, which means I can sell it and the investor gets a portion of that sale, right? My investors get return on the fact that I improved that sold out plant. Soft dollar savings would be, I'm doing the same thing, but for a plant that's not sold out. I'm improving the ability to make more product, but I am not selling that product. Now, anybody in the chemical industry will say, well, gee, that's a good idea. But the investor will look at you and say, yes, but you're not making me any more money. So that's soft dollar savings. This was a phenomenon that became big in my company 5 to 7 years ago. I assume they're still talking about this. Used to be all I had to do was demonstrate the value I wasn't sinking into pouring down a drain by improving how I operated a plant. But now it really boils down to, is an investor going to see a financial return from my investment in these tools into the enterprise? So how do you, what kind of, so hard dollar is the investor sees return because you've increased production, or by the way, there are some cases where you've reduced the insult to the environment and you've avoided the government coming in and fining you and this and that and the other, and the investors do see value in that. But soft dollar, that people argue that's hard or soft. Soft dollar savings are things that the investor will never particularly know about, but are really good for the plant. So here's the deal. I one time helped, my colleagues helped a plant move a turnaround. A turnaround is a complete complete clean out and refitting of a chemical plant, which you do occasionally just because you need to, right? Things wear. They would do it on a schedule, every 5 years, every 10 years. And well, if we're using AI properly and we're doing our fundamentals properly, we might put less stress on that plant, so therefore it can last a little bit longer. So if I want to go in and say, I'd like to use this tool to help me improve the cycle time of my plant so I don't have to shut it down quite as often, I used to claim that, look, I've saved all this money over that period of time. But the accountants will come back and tell you that, yeah, but you still spend the money at some point. You still turn the plant off at some point. So you've deferred the savings. You haven't eliminated the savings, right? And this was a big deflator for me because it used to be that if you could extend a plant's runtime, or you could reduce the fouling in the plant, or do a bunch of other things in the plant to make it operate more efficiently, you made the workforce a lot happier. You made the vice presidents in manufacturing a lot happier because their phones stopped ringing because they weren't getting all these complaints from people in the business about, why is your plant operating that way? But really, the accountants would come back and tell you that's all soft dollars, because in the end, we're going to follow the molecule all the way through the chain in the plant into the customer's application. And we want to know what money we made on that molecule. And, back to the question, are you going to operate a plant with AI or not? The amount of money you'd have to invest in the plant to run it by AI now would kill all the value you're going to get in that molecule going to that customer. You wouldn't make any money. Just don't do it. And so you can still, by the way, I'm telling you this because we still do all these things. We still improve the operations in our plants. We still do everything we can. But the question is, are you going to invest more money in technology than you already have, right? It's not that we don't do these things. It's that, well, can we do them better? Can we do it with a different resource load? I honestly would love that my chemometricians were no longer required to be a separate organization in Dow doing this high level work, because everybody could do it. That would be wonderful. So there, by the way, is a hard dollar savings, because you're reducing the number of people you're paying to support these tools, and the investor gets money back on that. But reality slaps us in the face. You got to have knowledgeable people involved in doing this, because by the way, AI is still complicated. It's still pretty complex. And statistics, by the way, used to be an optional class in engineering. I don't think it is any longer. Many universities are now offering a master's program. If you stick around in grad school one more year with your engineering degree, and you can get a master's in data science to go along with it. Boy, that's a powerful tool. And those, by the way, are the people you'd love to see coming into a chemical plant to work. So I think it's slowly but surely going to get there, but in the end, the companies will try things out. They will play with them. They will get vendors excited that, oh, gee, they're coming to work with our tool. But I saw too many times we use it for a while, but realized we could do the same thing using other tools, and we'd say thank you, and we're done. And oh, by the way, one of the other problems I talked about in the paper was the security of data. There's a lot of models out there where companies want us to upload their data into a cloud, and then they'll help you debride the data and help you sort it, parse it, and help you with it. The world is a pretty scary place from a chemical company's view for information and data sitting outside of its firewall. We get enough attacks as it is within our own firewall. And by the way, the most valuable information in the chemical industry today is actual process data. It's not the papers we've written about the plants. If I had a couple of chemometricians, an engineer, I knew what the data was from, what kind of plant it was from, I wouldn't need to know the details of the plant itself to be able to break down the unit operations based on the data signatures. It wouldn't be easy, but I could certainly do it. And I don't, by the way, need to go out and take pictures surreptitiously from the highway as companies used to do with each other. That was a real thing in the 70s and 80s, by the way. Industrial espionage. So the chemical companies, if the data got out, that would be the worst of all possible scenarios.
Can you speak to the role of humility in the pursuit of knowledge, particularly in the context of analytical chemistry and data science. How do you stay open to new ideas and approaches while maintaining your expertise in these fields?
Okay, appreciate what you do know and what you don't know. The one thing here's an example. I was a chemical physicist, but I did a lot of analytical chemistry in college and even in Dow when I was in R&D. I never once asked myself, what was the actual measurement capability of any particular measurement? Is that sensor good to plus or minus a degree? Is that pressure good to plus or minus 5 or 10 torr? Engineers rarely ask their question in a batch plant, what is the accuracy of that micromotion pump that's pumping water or some chemical into a giant reactor? Yet Six Sigma taught us that these aspects of our measurement science are important and we have to incorporate it into our decision making. And AI, by the way, has demonstrated this. Once we started running our plants better real time, the fog of data uncertainty in data sets we get would shrink. That's pretty powerful when you take all the noise out of the measurement systems that you didn't really think about having noise, and all the noise out of a process when you're over controlling it. Over controlling it means you see a trend, you think it's a real trend, and you adjust the plant and you yank it down to a different point, when in fact the trend was just a statistical anomaly within the plant's normal operating, right? So I didn't think about any of that, and I had to remain open to it. And Six Sigma, although I never had formal Six Sigma training, I certainly know what the process espoused. And even people that would go through that training would come back and forget that data has uncertainty, and would forget that data that plants would normally trend over a period of time. No plant is going to be held within two specific limits hard, but that you needed to understand that fluctuation in a plant's lifespan, and AI helps you understand that. So there were a lot of people that got in my way simply because they refused to think about the trust they were putting in their data. And what I want is for engineers and chemists to understand that you need to think about that more. I wish I had thought about it more in graduate school. It's not data paralysis, it's just incorporating that uncertainty into your calculation. I would like engineers to not assume that once they've been through a PowerPoint presentation on a plant they just walked into, that is knowledge. I taught people in Dow 5 basic questions to walk into a plant and ask the engineers, just to test to see if they have any understanding what they're doing. It had nothing to do with specifics about the process they were working on. It was designed to give me information about whether I had any confidence if they really understood what they were doing. I know they understood engineering. They got a degree from some great universities and understand engineering, but do they really understand what the kinetics and how the plant's running? Even if I didn't understand it. And if I got a general signal that they really had no idea what they were talking about, I would make sure to introduce them to somebody who already knew what I was worried about, and they'd go in and teach them. So I would like everybody to come out of college with an understanding that college has exposed you to an enormous amount of information. But knowledge comes mostly from application of that education and gaining experience. And I would ask the young engineers in the plants, if they don't have a tool or technology more powerful than Excel and dumping data into a spreadsheet, we've gone way beyond that now. Start asking questions and get it from somewhere. And oh, by the way, get the right tool for you in the right context. What are you trying to solve? And companies like Soothsayer are really supportive in helping people to figure that out. You guys walked away from some things because you said that's not what we're in. I respected that. Other people didn't. So people need to understand that they need to understand what they want to target, and then they need to go out and ask a breadth of experts what might be the best way to go do that. In Lord of the Rings, there's the one ring, right? The one ring that rules them all. There isn't there isn't one tool. If there is, I haven't seen it. Although there is one tool, by the way. If you are a OSI Pi user or an Aspen Tech user, those people will tell me they can do anything in that framework. Yeah, when I asked them to do it, it would take them 6 months to go figure it out, maybe a year. They'd come back and show me what they had when they could just as easily bought some software and gone out and done it based on the external market. And that software they're buying, other people can use. What they've created within the framework of OSI and Aspen is for their use. And no engineer sticks around a plant long enough to make that pay. So let's get a tool that everybody can use and that somebody else is responsible for managing its health and efficacy, right? I want something that's going to work. If it needs to be updated and upgraded, I don't want links to be broken. Hey, Dow, we were experts at programming Excel, but then every 5 years, Dow would go to a new workstation and all the links and all the things and all our neat little Excel tools would be broken, and people would spend months trying to cobble these things back together. That was happening to me in the 90s and early part of 2005 to 2010. Drove me nuts. Well, not 2000, then I'd given up on it. I love Excel. Excel is like a calculator you have in your desk. I don't use calculators anymore. I use Excel. Or actually now I use my iPhone. But the point is, that's all it should be. Don't make it more than it is. And get the right tool for the right job. So these are some of the other challenges that vendors face coming in and that companies face trying to adopt new technologies. Is there anything I missed maybe that?
Yeah, I was just wondering, I mean, at what point did you guys start switching some of the analysis over from like an Excel to like an R Python kind of thing?
That was, I would say, for the true people who knew how to do that, that was happening in the 90s. It started happening more in our engineering functions around 2000, plus or minus. I think Python, my daughter knows how to program in Python now. That was not, as far as I know, wasn't an option except for computer science geeks in the 80s when I was in college. I don't know that I want every engineer walking into my company to have that kind of programming capability. I would like some people that just have capability knowing how to use design tools. You only have so much discretionary time. You can either fill it programming or you can fill it problem solving. So do that, do one or the other, but doing both just gets kind of messy unless you have a unique job that allows you to do those things.
You've given an immense amount of insight and recommendations. So instead of, just asking for parting advice, maybe we can just mix it up for a second. And if you had to choose between working with a team of chemists who only spoke in chemical formulas or engineers who only spoke in technical jargon, which would you choose and why?
I would, well, okay, I'm biased. I had to work with the engineers. I would choose them. It's more valuable to understand the realities of production than the realities of the chemistry, in my mind, in my opinion. I will say that I think I can teach chemistry to engineers more quickly than I can teach engineering to chemists. And if the chemists just come up with the chemical pathways that are appropriate, all my questions are for the engineers. What's the capability of your process to meet these tolerances? A classic problem in the chemical industry when I was in R&D was customers wanted certain specifications for products they were getting from Dow. And as an R&D person, I would go to the plant and say, we want to change the specification on this product. The mistake the plants made was to say, okay, you go into our SAP system and you change the tolerances and you start making that product. What did we forget to do? We forgot to engineer the plant to meet that specification. We were still making the distribution the plant was designed to make, but then we were looking for some sub-slice of that. And then when we couldn't make it, because maybe we couldn't control in the variation of the plant, in the normal variation of the plant, maybe we didn't spend enough time understanding control in that space. All of a sudden, we'd shut our customer down because we couldn't make exactly what they wanted. And I did, as a quality director for 7 years in Dow, I did spend a lot of time understanding process capability in a whole bunch of processes, and sometimes telling our commercial group, don't make that commitment to that customer, because we can't control the plant to assure that they will always have supply of that. And commercial would come back and say, well, what's it going to take to do that? I said, we need to design a plant that will make that product. And that'd usually kill it. Chemists wouldn't balk at the idea of, yeah, we can make it. It's the engineers that need to balk at the idea of, well, we can just change some numbers in a specification and make the product. So it really gets back to the wild west of the chemical industry, which was happening in the 40s, 50s, and 60s, when our customers weren't that sophisticated and we could make pretty much anything and they'd consume it. Well, now our customers are very sophisticated in the chemical industry, and we need to be careful what we commit our assets to. And what we commit our assets to is based on process capability, and not just the overall process capability, but sometimes subsegments of that. And back to AI, it will help us make better decisions by doing that.
This was excellent. Thank you so much for your time. Anything else that you want to add or you want to shout out?
Well, Chris, I'm sure I'll think of something later and I'll send you a note. If we need to add something, we can, but no, that's good for now.
This was excellent. Thank you, sir.